Hey guys, welcome to this video lecture series on the subject of energy technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have seen the different instruments that are used for the measurement of solar energy. We have seen the pyranometer, then pyroheliometer and sunshine recorder in order to measure the solar radiation. Well, if you have missed that video, you can find it in the I button over here. Now in this video, we are going to start the new topic in the solar energy as the solar energy storage system. Well, the viability of solar radiation at any particular location is variable and unpredictable. An optimally designed solar electrical system will collect and convert this solar energy into electrical energy when insulation is available during the daytime. Hence, during the night time, this optimally designed solar energy device will not work because there won't be any solar radiation during night time. Hence, to supply continuous solar energy or electrical energy, one storage device is always required. So here in the animation, you can see that we can store this solar energy in number of ways and utilize during the night time when there is no sun. Therefore, the storage device for solar energy is always required for smooth supply of electrical demand. Generally, these storage devices can be classified as follows. So here you can see the complete classification of these solar energy storage devices. As the thermal energy storage device, which include sensible heat and latent heat storage devices. While these sensible heat storage devices include water storage and pebble bed storage. The next classification of these storage devices is chemical storage, that include chemical and thermochemical storage devices. The next storage device is electrical storage, that include capacitor, inductor and battery storage. Then we have mechanical energy storage as pumped hydraulic storage, compressed air and flywheel. Lastly, we can store this solar energy as electromagnetic energy. So this was complete classification of solar energy. Well, mainly we store this solar energy in the form of thermal energy by means of water storage or air storage. So let's understand in detail what is this thermal energy storage. Then we will understand this chemical storage and electrical storage as well. So the first is thermal energy storage. Energy can be stored by heating, melting or vaporizing of material, and the energy become available as heat when this process is reversed. So we can heat up certain kind of material, that is metal or liquid, and store this heat energy inside that material. So when this process is reversed, this heat can be extracted from such materials. There are basically two different type of thermal energy storage devices as sensible heat and latent heat storage devices. It is possible for both sensible and latent heat storage to occur in the same material. As when solid is heated, then melted, then it is raised further in the temperature. So one solid material can store the sensible and latent heat at the same time. So let's understand sensible heat storage devices first. Well, the heat storage by causing a material to rise in a temperature is called as sensible heat storage device. So we store this heat inside the material by increasing the temperature of material. The sensible heat storage involves material that undergo no change in phase over the entire temperature range involved. So such kind of storage devices does not involve any phase change. The basic equation for this energy storage can be defined as Q is equal to mCp T1 minus T2. Well, this is the basic equation that we have already understood in the thermodynamics for the calculation of heat duty. So here is the T1 and T2 are the temperature different, where m is the mass flow rate of thermic fluid and Cp is the specific heat of this working fluid. Majorly, water is used as the working fluid for such application. The most common heat transfer fluid for solar system is water. And the easiest way to store thermal energy is by storing water directly in well-insulated tank. So what we do is, we provide an insulated tank inside which we store this hot or warm water for its further use. So when we require such heating application, we utilize this hot and warm water for such applications. Since water is inexpensive, readily available, and it has high thermal efficiency, so we always utilize this water as the working fluid for the sensible heat storage. Water storage with the flat collector is shown in this diagram. So you can see in this image on the left hand side that we have used this simple flat plate collector, which basically collects all the solar radiation and focuses into the working fluid of the water. Now this water is then stored inside the storage tank, which is well insulated, so that we can reduce the losses towards the environment or the atmosphere. So when this hot water or heat energy is required, this hot water is then supplied to auxiliary heat exchanger and then to hot water load. So this was all about sensible heat storage systems. Now let's understand about the latent heat storage system. In this system, the heat is stored in material when it is melt and extracted from the material when it is freeze. There are several materials that undergo no change of phase, such as gobar salt as Na2SO4 into 10H2O and different eutectic salts. In latent heat storage, material is placed in the long thin container such as cylindrical, and the gas is passed through narrow space between the tubes. So here in this diagram you can see the typical latent heat storage device, which is nothing but which look like an heat exchanger, inside which the tubes carry such material such as this gobar salt and different eutectic salts, while the gaps between these tubes provide the passage for the air flow or the gas flow, so that we can heat up this air or the gas. So this was all about latent heat storage devices. Now let's move to the next type of storage device, and that is electrical storage. Well, batteries are largely used for the purpose of storing solar energy as electrical energy. A battery is the combination of individual cells, and a cell is nothing but the combination of electrode and electrolyte material, which is combinedly known as electrochemical energy. Electrical storage can be classified as battery, capacitor and inductor storage. So here in the image you can see how we are utilizing battery for the storage purpose of this solar energy. So during the daytime, this solar panel absorbs the solar radiation and convert it into the electrical energy. And this battery stores this electrical energy so that we can utilize this electrical energy when there is no sun or in the night time. Now let's discuss the mostly asked question in the exam, that is solar ponds. The solar pond is natural or artificial body of water for collecting and absorbing solar radiation and store this as in the form of heat. So here in the image you can see one solar pond that is utilized for storing and absorbing this solar radiation. So in the natural pond, some part of the solar radiation reaches the depth of 2 meters, and this heat energy is absorbed by the water at the bottom of the pond. As a result, the temperature of water increases and this warm water becomes light in weight because of its density is lower than the surface water. And this water, which is light, travels upward in the surface, creating convection current. So when this light water, which is warm, reaches the surface, it loses this heat energy to the atmosphere. So by means of such natural pond, we cannot utilize the solar energy for different purposes. So what we need to do is, we have to eliminate this density difference that causes this conventional current. Well, a solar pond is mass of shallow water about 1 to 2 meter deep with the large collection area which act as the heat trap. So basically this solar pond is nothing but it is a pond which is made up of salt material to store this heat energy coming from the solar radiation. The loss of heat energy due to density gradient in a natural pond can be eliminated by dissolving salt in the pond to generate stable density gradient which eliminates the convection of warm water. So in order to eliminate the difference in the density, what we do is we dissolve salt inside the pond so that we can eliminate the conventional current of this water. Salt like magnesium chloride, sodium chloride and sodium nitrite are dissolved in the water. The concentration of salt varying from 20 to 30% at bottom and almost zero at the surface. So the salt concentration is highest at the bottom part of the pond and it is lowest at the surface of the pond. So the salt concentration is very low at the surface, about less than 5% by weight, and thus the water is relatively light than the water at the bottom, with the concentration around 20 to 25% by weight. There are basically three main zones in typical solar pond, as surface convective zone, which is having the thickness of 0.3 to 0.5 meter, and the salt concentration is typically less than 5 meter. Then the second zone is the non-convective zone. Well, this is the largest and biggest zone in the solar pond, which thickness is around 1 meter to 1.5 meter, and concentration is continue to increase as we go deeper inside this layer. And the last zone is known as the storage or convective zone, which thickness is around 0.3 to 0.5 meter, and its depth is around 1.5 to 2 meter. Well, its concentration is highest in the range of 20 to 25%. So here in the image you can see the typical diagram of solar pond, which basically has the three layer. The upper layer is known as the convective layer, while the second layer is known as the non-convective layer, and lastly we have storage layer. So as we go deep inside this layer, the concentration of salt also increases and the temperature gradient also increases. So the surface convective layer has the lowest thickness and it has low and uniform temperature and the concentration throughout. So here in the graph you can see at the top of the layer, that is the upper convective layer, its thickness is around 0.5 meter, while the temperature is nearly uniform and the concentration is also uniform up to 5%. Then it is followed by non-convective layer, which has the highest thickness around 1 to 1.5 meter. Well, its temperature and concentration graph also continue to increase linearly as we go deeper inside the layers. So from the graph you can see it is linear. The lower convective zone, which is also known as the storage zone, has more or less similar thickness as of the surface convective layer. The temperature and concentration in this zone are nearly constant. This zone acts as the mainly solar energy collector and storage device. So here in the image you can see the bottom layer, that is storage layer, also acts as the collecting and storage device for this solar pond. We can utilize this solar energy by inserting one heating coil or different organic fluid that has the lower boiling point. So this was all about the solar pond. Now let's quickly discuss about the application of solar ponds. Heating and cooling of the buildings. Solar pond has large heating storage capacity in the lower convective zone. It has ideally used for heating application even at the high altitude station where cloudy nature or cloudy atmosphere is present. So we can utilize this solar pond and this thermal energy of this solar pond for heating and cooling application of buildings. Then we can utilize this solar pond for the power generation. Solar pond can be used to generate electricity by driving thermoelectric devices. Turbines powered by evaporating a secondary fluid which has low working fluid can be utilized for generation of electricity. Here in the image you can see that typical diagram of generation of electricity by utilizing solar energy. We are using secondary fluid which has the lower boiling point for generation of high pressure vapors. This vapor then runs the turbine and generator in order to produce electricity. Now let's discuss the next application of this solar pond is the industrial processing. Well, thermal energy from solar pond can directly used in the preparation and treatment of material and goods manufactured by the industry. So we can directly utilize this thermal energy from the solar ponds for generating or producing the different goods and processes. Economic calculation shows that crop drying and paper industry, the heat from the solar pond is highly competitive with oil and natural gases. So different calculation shows that the paper industry can utilize this solar pond and thermal energy from the solar pond at competitive rate for the natural gases. Then we have heat for the biomass conversion. Inside builded solar pond could provide heat to convert this biomass into the methane and different natural gases. Then we can utilize this solar pond for the desalination. The low cost thermal energy can be used to desalt and the purification of the water. So by using desalination, we can purify water by utilizing solar ponds. Around 4,700 meter cube per day of distilled water can be produced with 0.31 meter cube of the solar pond area. So this was all about the solar energy and storage of solar energy. We will see you in the next video. Till then, keep watching, keep learning. Thank you.